Today let us do physics. Practice problem 1. We have a ray of light. Okay, there is a glass slab. So a ray of light strike the glass slab in such a way that we have the refractive index of the glass is equal to 1.5 and at angle of 37 degree. Here we have strike a glass slab at an angle of 37 degrees. So clearly 37 is the angle of incident. Then we have to find the angle of refraction. So we have here refractive index. We used to denote what n equal 1.5. So since they say strike at an angle, this show it is angle of incident. We used to denote with I equal to 37 degree. It's already given sine 37 to be 0.6018. For easier calculation, let us take it approximately 0.6. We have to find angle of refraction. We know from Snell's law, sine I by sine R equal n. I we know it is 37 degree. We replace it. Then sine R we still have to find. Let it be there. N we know 1.5. So here sine 37 we already have the value. We take it approximately 0.6. Then sine R. Now we want to find sine R. So that's cross multiply. Sine R you take it up. 1.5 you take it down. We have the decimal. So try to remove the decimal. We have one number of decimal below, one number of decimal behind, above. So in order to remove the decimal, we should put 1 0 up and 1 0 down. So 0 0 cancel, 6 we can cancel with 3, 3 into 2, 3 into 5. So 2 if we divide by 5, we get 5 0 0 2 point, we have 0 0.4. So 0.4 we already see that it is equal to approximately sine 24 degree. Here we have 0.4. Okay, approximate, that is sine 24. So instead of putting 0.4 we can replace with sine 24 degree. So sine and sine get cancelled. We show that the angle of refraction is equal to 24 degree. Then next, number 2, we have the ray of light strike the surface of water at an angle of 30 degree. So since the light strike the surface, it shows that 30 degree is the angle of incident. The angle of incident is 30 degree. Then the angle of refraction is given to be 22.1 degree. Now what to do? We have to find the refractive index. Then here the value already given. Sine 30 equals 0.500. We can take it as 0.5 approximately. Sine 22.1 degree, we can take it 0.37, or this is 6. If we correct it, it become 0.38. But easier calculation, let's take only 2 number after decimal. So that is 0.37 degree. Okay, then we know from Snell's law that n equals sine I by sine R. Angle of incident is equal to 30 degree, already given. You can replace. Angle of refraction we have 22.1. Then sine 30 we know it is 0.5. Sine 22.1 we can take it approximately from here, 0.37. If correct to 1 decimal places, this is more than 5, so we can add 1. Okay, so in order to calculate, let's remove the decimal. Here we have one number after decimal, here 1. To remove decimal, put 1 0 up, 1 0 down. 0 0 cancel. So 5 if we divide by 4, then we get it 1.25. Correct it to 1 decimal places. The refractive index of water, it is equal to 1.3. Then here we have the second problem. We have the velocity of light in air is 3 into 10 to the power 8 meter per second, and the velocity of light in glass, it is 2 into 10 to the power 8 meter per second. we have to find the refractive index of glass. So it's already given. Velocity of light in air, we used to denote with c, equal 3 into 10 to the power 8 meter per second. Velocity of light in glass, we denote with v, equal 2 into 10 to the power 8 meter per second. So we know the definition of refractive index. Another definition is velocity of light in air by velocity of light in glass. So we replace the value what we get. Okay, velocity of light in air, we get 3 into 10 to the power 8 meter per second. Value of velocity of light in glass, we have this one. So meter per second cancel with meter per second. 10.8 with 10.8, so 3 divided by 2, we get 1.5. So because here we have same unit, they get cancelled. Refractive index is unitless. Then we have number 2. The velocity of light in air, it's given to be 3 into 10 to the power 8 meter per second. Then we have to calculate the velocity of light in diamond, where the refractive index of diamond is given to be 2.5. So as usual, we already know the refractive index definition equal to velocity of light in air by velocity of light in diamond. Refractive index, we know 2.5, we replace. Velocity of light in air, we know 3 into 10 to the power 8 meter per second. Velocity of light in diamond, we still have to find. So what to do? We exchange this one. Velocity of light in diamond, it will be equal to 3 into 10 to the power 8 divided by 2.5. In order to divide, we have decimals, so let's remove decimals. How to remove the decimal? By putting 0. We have one number after decimal down, so we put 1 0 up. So here we can have 5 into 6, 5 into 5. So 6 divided by 5, we have 5 1. 5 into 2 will be 10. Then into 10 to the power 8 meter per second. So the speed of light in diamond, it is equal to 1.2 into 10 to the power 8 meter per second. Then next practice problem 3. Here we have the wavelength of particle light, it is 600 nanometer, and then the refractive index, it is 4 by 3 when it enters from air to water. We have to find the speed, the frequency, and the wavelength in water. So those. We know the definition. Refractive index is equal to wavelength in air by wavelength in water. Then we know already given refractive index equal 4 by 3. Then wavelength in air already given here 600 nanometer. Then next we have to find the wavelength in water. So let us cross multiply here. 3 into 600. Then 4 will come down. Then wavelength in water will go up. We exchange position. So 600 divided by 4, we will get 150 divided by 3. So the wavelength of light in water, it will be equal to 450. Then we know that we have to find another one, velocity of light in water. So we have another definition. Refractive index, velocity of light in air by velocity of light in water. Again, the refractive index we know 4 by 3. Then the velocity of light in air we know 3 into 10 to the power 8 meter per second. We want to find the velocity of light. So same way here, we exchange the position. Velocity of light in water, we take it up. 4, it comes down. 3, it is cross multiply this side. So the velocity of light in water, we will get 3 into 3, 9, divide by 4. This one, let it remain same. So 9, if divided by 4, we get 2.25. Then this one remains same. So the velocity of light in water, it will be 2.25 into 10 to the power 8 meter per second. Then next, we have to find the frequency. But we know that the frequency of the wavelength does not change. It remains the same. Only velocity and speed change. Number 2, again, we have to calculate the speed, the wavelength of light in diamond. And then the wavelength is given to be 800 nanometer in air. Refractive of diamond is 2.42. The speed of light in air is given to be 3 into 10 to the power 8 meter per second. Then we know the formula of refractive index. It is equal to speed of light in air by speed of light in diamond. Refractive index already given 2.42. Speed of light in air, we know it is 3 into 10 to the power 8 meter per second. We have to find the speed of light in diamond. So here we exchange a position. Since we have equal, this one we take it up, this one come down. So here now for us easy to divide, we have two number after decimal. We can remove first the decimal. How to remove? By putting 0. We have two number after decimal, we can put 2 0 up. So 300 divided by 242, we get 1.23. 10 to the power 8 meter per second remains same. So the speed of light in diamond, it is equal to 1.23 into 10 to the power 8 meter per second. Another definition for refractive index, we have wavelength of light in air by wavelength of light in diamond. Refractive index, we already have 2.42. The wavelength of light in air, we have 800 nanometer, already supplied by the question. So we have to find the wavelength of light in diamond. Then now we have here equal, so we can cross multiply. Okay, so we will get the wavelength of light in diamond will be 800 by 2.42 in order nanometer. In order to divide, since we have two number after decimal, we put 2 more 0 up. So if we divide it, we will get the wavelength of light in diamond, it is equal to 330.57 nanometer. The numerical problems, please practice yourself from the book.